Hello and welcome. My name is Leonardo Lapidario. This is the first update presentation for the Data Analytics 670 Capstone project. In this presentation, we will cover an executive summary of the Capstone project, the project scope, and the different dataset exploration. Life expectancy and mortality rates is a topic that will continue to be of extreme importance, and I predict that life expectancy will only continue to increase over the future. With the recent coronavirus pandemic that has become so prevalent to the world, and especially in the United States, since the confirmed cases surpass any other nation, life expectancy and mortality rates have become a hot topic again. The ultimate measure of the success of health and human service is quite simply one's life expectancy. The project will look into different mortality rates by location, as well as additional demographic information such as income, population, and employment, healthcare spending, and information in restaurant and grocery store numbers across the nation. During the time period of 1980 through 2014, the average life expectancy in the United States has increased from an average age of 73.75 years to 79.08 years, which is just over 5 years. The rise and fall of different diseases and disorders, along with the higher spending in healthcare, has certainly played a large role in the increase for these numbers. There are additional pieces of information and variables that will be analyzed in this project, which will aim to grasp a better understanding of what actually drives life expectancy in the United States. While the mortality risk for all age groups has gotten lower during the 35-year stretch, the reasons behind the fall need an explanation. The main problem that will be analyzed over this project will be to determine what factors have an effect on a person's life expectancy. Instead of the classification machine learning algorithm that has been a large focus on during the UMGC coursework, this problem poses a regression analysis as a person's life expectancy as the response variable. From the main data set, the data is presented based on the United States, state, and county. The basis of the Capstone project is to look into mortality rates, life expectancy, and the leading causes of death across the United States. The scope will give us a better understanding of life expectancy across America and show how it has fluctuated over the last 35 years. The mortality rates of different diseases, disorders, and surgeries that could either have become more or less prevalent over that time period will be investigated. Other factors that will be explored in the secondary data sets will be socioeconomic, demographic, and health related information. By looking at this information by region as well as looking into some of these other factors, the hope is to have a better understanding of what truly drives life expectancy. The data from the main dataset as well as secondary datasets are presented from the time period of 1980 through 2014. The intent is to look at the data in 5-year increments in order to have the appropriate amount of data. Finding additional information in datasets for the specific time periods that relate to the main dataset has been a bit of a challenge. However, due to the wide variety of factors that make up the demographics of a county or state, there has been plenty of options. Life expectancy and mortality rates is a topic that will continue to be of extreme importance. With all of the coronavirus and the global pandemic that has become so prevalent in the world, life expectancy and mortality rates have become a hot topic again. Global events like pandemics certainly have an effect on life expectancy, but there are many other diseases, disorders, or surgeries, and anything else that can play a huge role. Across the different regions of the United States, there could be higher disease or surgery rates, more fast food restaurants, different levels of healthcare coverage, levels of education, different crime rates that play important factors. Determining which of these factors are most important or have more of an effect on life expectancy is what drives the importance of this project. The main business industry for life expectancy and mortality rates falls under the healthcare industry. The problem that will be solved will be to first determine what factors play the most important roles into determining the life expectancy of someone in the United States. These factors can be anything from the mortality rates of an area, the location itself, population, healthcare spending, income, education, crime rates, among many other things. Within the healthcare industry, and generally speaking, life expectancy has a broader category of human well being. Healthcare and the care of human life will always be extremely important to the United States and to the world. The healthcare industry overall is so vast and large. There are many different healthcare companies, which can include acute and ambulatory surgery centers, physician offices, urgent care centers, behavioral health, and many others. There are manufacturers and vendors of medical products. There are group purchasing organizations who write up contracts with medical device companies. Within this space, the care and improvement on human and patient health is so critical and important. Life expectancy, mortality rates, and other drivers into a person's life expectancy are an integral part of within the healthcare industry. A few different organizations or types of organizations come to mind when talking about human life expectancy. One of these organizations is the World Health Organization. Because life expectancy or mortality rates typically have to do with the health and life status of a human, the agency who specializes and is responsible for public health across the globe is critically important. Another important organization is the Centers for Disease Control and Prevention. Mortality rates are also included in the main data set, and the CDC is the leading health institute in the United States. A lot of mortality data comes from the CDC. Healthcare companies and hospitals are other organizations that this problem relates to. The front lines of being in the hospital and treating people with disease or operating and performing surgeries cause the healthcare companies to be a main organization for this problem. Some of the stakeholders include everyday people. First and foremost, an everyday American would be very interested to know more about their life expectancy. Deciding on the type of lifestyle or the location to live one's life could have an effect on life expectancy. Another stakeholder could be physicians, doctors, or surgeons. There is a potential to see the strength of certain surgeons or procedures by a location, but this also depends on what additional data is included in the project. Third and final stakeholder could be the hospitality and service industry, particularly food and restaurant. Within the data sources that provide some of the secondary data, there's a data set that provides information on grocery stores, fast food restaurants, and full service restaurants. The business area for this project is human life and lifestyle in general. And looking at the life expectancy across the nation, it will be interesting to determine what locations have longer life expectancy and the reasons behind that. The main business area for the life expectancy and mortality rates will fall under the healthcare industry. A lot of the data provided in the main data set is based on the mortality rates across a 35-year time period for different diseases, disorders, or surgeries. While healthcare and human health would be the main business area. Secondary data sources provide additional information such as demographics, regional information, including population and education, and many other variables. Secondary data falls under just human and general everyday life business realm and will hopefully enhance the healthcare portion regarding life expectancy and mortality rates. The main business objective will be to determine the most important factors of the life expectancy in the United States population. The mortality rates of different diseases and disorders are continuously fluctuating, especially across the different time periods and regions in this country. This could be due to better healthcare or doctors providing assistance or the advancement of technology in medicine. There could be education levels that vary across the country. Healthcare and medicine, education, and crime are just small portions of the question to the bigger problem of the leading factors in life expectancy. A second business objective is to act as a guide for the human species across America. Hopefully, at the conclusion of this project, there will be a better understanding of what factors play a larger role in the life expectancy across the nation. The hope is to tell a better story of what factors someone can look to when planning their life. There are certainly behaviors or habits that people should avoid in order to lengthen their life, but what do we know what they actually are? The final business objective is to present an appropriate and well-planned project. In order to accomplish this objective, it's most important to just dedicate the man hours and to ensure that deadlines and assignments are kept up with. A successful project and case study should not only be determined by the model accuracy for regression modeling, but there should be many other different success factors. Important success factors for this capstone project will take into consideration and utilize all learned information from the previous 5 courses under the UMGC framework. The important critical success factors for this specific project are as follows: relevancy and quality of the data sources, variables with a strong correlation and significance towards the response variable, clear business goals and measures for the KPIs, business and data understanding and separation. If these 4 aforementioned success factors are met, then the desired outcome will be more than likely realized. There would be a hope that at the end of the project, there would be somewhat of an answer as the main and secondary causes of life expectancy, and a predictive model will be built in order to determine life expectancy. The necessary conditions that should exist start with a relevancy and quality of the data. If the data sources are relevant, then there should be some variables in the data that have a strong correlation with life expectancy, and these variables would actually be considered significant. The business goals of this project will be to present with an accurately tested and evaluated model for life expectancy. The proposed tools of RStudio, possibly Python, SPSS Modeler, and Tableau will provide the legwork on data exploration, preparation, and cleansing, analysis and modeling, and model evaluation to ensure that these critical success factors are met. The goal of this project will be to look into other factors other than what is provided in the main data set on the mortality rates for different diseases, disorders, or surgeries. There are many other data set options for the secondary data sources: demographic features, social features, health care coverage information, and many more options will hopefully be a complement to the mortality rates and their effects on the life expectancy across the nation. The different time periods provide additional information and show the changes over the years as well. This project aims to determine a better understanding of life expectancy across the United States while potentially predicting how it can fluctuate in the future. There have been quite a few different case studies with regards to life expectancy and mortality rates that have been published already. Many of the more current studies have shown that life expectancy has a relatively increased moving forward compared to the past, with some of the recent years bringing a small decrease in the age of life expectancy. The different diseases and disorders that have risen up recently can be certainly be attributed to this uh, recent decrease, but there are also some other reasons that need some explanation. Some of the studies that have shown and given detail about behind why life expectancy has improved globally across the world, with one of the main reasons being that child mortality rates have gotten lower. For this project, information will be analyzed based on mortality rates over time, in addition to secondary data, including demographic, social, economic, and healthcare information. The secondary sources will complement the mortality rates and hopefully provide additional insight into life expectancy. These secondary data sources are the gap that will be filled within this specific project. The decision on how many variables should be looked at and included will be key to bridging the gap with the other research that has already been performed. Building a wide variety and high number of models will also be different than the other studies. When determining the project and the background of the industry, the first intent was looking in healthcare. I've been employed in the healthcare industry for my entire professional career, so determining to do the project in the healthcare industry was an easy decision. Given the recent global pandemic, life expectancy and mortality rates have become a hot topic of conversation. People are paying more attention to the coronavirus mortality rates, and that are having an effect on overall mortality rates by global disease and life expectancy in general. Because of the outbreak and the fact that the life expectancy is in the healthcare realm, the choice was made to research the leading factors and causes to one's life expectancy for the Capstone project. One of the biggest measures of success in the health of human life is one's life expectancy. Obviously, mortality rates plays one of the bigger factors in determining life expectancy since they're related directly to life and death. Other factors that will be considered in the project have hopes to play an important role in the success. Model development and evaluation will show which of the additional secondary variables factor into life expectancy. The measurements to success of the project are necessary in order to achieve the business objectives, understanding, and goals. When looking at life expectancy in the scope of the project, the different success factors will play an integral part of the success in this project. Since there are multiple data sets being analyzed for the project, one of the important factors is to ensure that there is some type of relation that will conjoin all the data. Ensuring that the organizations and stakeholders' needs are met and the business domain is considered also will need to be evaluated. For this particular project, there can be four specific key performance indicators that will drive the success. These KPIs include the leading cause of death, model accuracy measures, the handling of missing information, and most importantly, the target variable of life expectancy. The leading cause of death are provided as insightful information from the main data set. As the data is presented in the form of mortality rates by country or by county and type, this allows end users the ability to have a better understanding of some important factors of life expectancy. Looking at different diseases, disorders, surgeries, etc., and their mortality rates by region will provide insight on life expectancy across the nation. Model accuracy for regression machine learning modeling is another essential KPI for the project. Under regression modeling, there are a few important measures and metrics that will let the end user know about the quality and success of the model. Some of those metrics are the R squared, adjusted R squared, root mean squared error, and even it can even be evaluated using training and testing split. There could also potentially be some missing data from the data sources, since there is a main data source and a number of different secondary data sources. There will more than likely be some missing information in data, and the way that this missing data will be handled is necessary to driving the success of the project. There doesn't need to be one right way to handle the missing information, and there can be multiple different ways for different variables. Some of the variables will be entirely complete, but for the variables that are not, it might be best not to include them. We'll have to see on that. The best measure of success in health can be seen as life expectancy. While life expectancy is the target variable for this project, it is also an important measure for not just the project, but also for human health and life. The way that the project presents life expectancy and assesses and analyzes the data that lead to shorter or longer life expectancy is a necessary KPI for the project. RStudio or Python will be used to clean and analyze the data. As mentioned previously, the ETL process is very important, and RStudio is fairly user-friendly in allowing for data cleansing and potential variable transformation and creation. IBM SPSS Modeler will be used in creating the predictive models and hopefully some ensemble models utilizing a number of different models. Tableau could be essential to visualize the data. Since there are different years and time periods for all the data, a time series plot could potentially be used. And there could even be some predictions done with this as well. So the main data set comes from the Global Health Data Exchange, which pulls from the Global Health Observatory data repository under the World Health Organization. The response variable and the predictor of this particular data set is life expectancy. The data is by the county level, and I decided to look into the trends of life expectancy by county from 1980 through 2014 in 5-year increments. The other variables of this data set are different mortality rates for different diseases, disorders, and surgeries. And looking at the age-specific mortality rates of this data set and by location, the goal of my project will be to determine the leading causes of death and predictors of life expectancy of different regions. Obviously, the hope is that the secondary data source will play a key role in determining life expectancy. Given the 35-year scope of the data, the mortality rates of different diseases, disorders, and surgeries could either have become more or less prevalent over that time period, and this will be investigated. Among the main data sets, some of the different mortality rates that are observed include infectious diseases, which I'm going to go to the next slide so you can see all the variables. So infectious diseases such as tuberculosis, HIV/AIDS, diarrheal diseases, lower respiratory, meningitis, hepatitis, some disorders, alcohol use, drug abuse, self-harm, interpersonal violence, maternal and neonatal disorders, cardiovascular surgeries, chronic respiratory disorders, diabetes, cancer, etc. And so there are, I'm going to go back to this last one. So there are 3,143 counties in the United States, and since there are 8 different years, 1980 through 2014 in 5-year increments, the main data set has 25,136 rows and 41 variables. I plan to adjust the number of variables by adding or removing some additional mortality rate information. And just keep in mind that this main data set is only mortality rate information and life expectancy. The secondary data sources, the plan is to try and find and pull together as much demographic, economic, and social information as possible. So far, there are 3 different secondary data sources, but the goal is to continue to research and find additional data sets as necessary. The first data set includes population, income, and employment data for the years 1980 through 1940. 1980 through 2014. This data set comes from the United States Bureau of Economic Analysis. The data set that is included the data that is included in this data set is population in persons, total personal income, and the total number of employed persons. There is a per capita personal income, but this accounts for the entire population, so it's going to be beneficial for me to create a different variable that just lists the per capita personal income for the employed population. The second data set that I've already found includes healthcare spending data for the years 1980 through 2014, and it's by state, so not by county for this one. This data set comes from the Centers for Medicare and Medicaid Services. The data that's included in this data is healthcare spending by personal, Medicare, and Medicaid by state. The spending is broken out into a category of aggregation that includes hospital care, physician services, other professional services, dental, home and health, prescription drugs, other non-durable medical products, durable medical products, nursing home care, and other health and residential care. And the spends in millions of dollars. The third data set that's included is food data, and unfortunately, it's just for the year 2014, but it's by county. So this data set comes from Sage Stats, and it includes the number of grocery stores, full-service restaurants, and fast food restaurants per 1,000 people. So this shows kind of the breakdown of each of the tables that I just went through. What's important is that for the county, there's a FIPS code, and that's how the secondary data sources are going to be connected to the main data source. For the secondary data source that was only by state, that's how that will be connected. Okay, right here, so what I'm showing on this slide is the high-level data diagram. So the first figure is a small data flow diagram that details the 5 main steps of the data science project lifecycle. Initially, the data selection step is deciding the scope of the project and figuring out what data sets are appropriate for desired goals. The first four data store nodes show the main data set along with the initial 3 secondary data sources. The main data set, which we'll have a deeper look into the next section, is the life expectancy and mortality rate data set. And the 3 initial secondary data sources are, as I already mentioned, are healthcare spending, income and education, or income and employment, and food and grocery. So the next steps on this specific DFD show data exploration and data pre-processing phase. So upon exploring the data steps that are essential are identifying variables, assessing and evaluating missing values, determining how to deal with these outliers, looking at the distribution of the variables, etc. So the pre-processing step under the data science lifecycle is more than likely the most time consuming, but it's extremely important. The next step is model development and creation, and that can take place after the pre-processing. In this step, many different models are built and ran. The final step, which is model evaluation, takes all the separate models that have been built and compares them with each other, while also looking at different metrics and measures that can help determine appropriate models. During the evaluation of the models can be adjusted or even combined to try and build the best possible model. The last step is model selection, and this is picking the champion model. The set figure on the right, so the second figure, shows the current data sources, the names of the tables, and some of the primary influential variables of each of these data sets. This is somewhat of an ERD diagram. It's not entirely one. The reason behind this is because the different data sets do not entirely have relationships with each other. The main data set has life expectancy and mortality rate information and is attributed by United States county and state. There's FIPS code information in some of the secondary data sources, but there's also the state. And so I already kind of mentioned this, but 2 of the secondary data sources have FIPS code associated with it, and that's how they will be joined. The third data source only has state information, so it'll be joined to the main data set by that. And finally, so for my last slide, I'm going to kind of talk about some potential data quality issues that could have an effect on the outcome of the model building. Since there's a lot of data in the main data set, there could be a possibility that the years provided is a little too much and that the data is repetitive, especially across the mortality rates. The data could also be a little bit inconsistent across the data sources. So while the main data source has information to the county level, some of the secondary data sources could only have information at the state level. And then also, we might not have all the years of the main data source, 1980 through 2014. As an example of this, the restaurant data is only from 2014. So the organization and combination of the data can also be a problem. If you'd offer any feedback, I'd greatly like to hear everything that you have. But other than that, I appreciate you listening on the first project update presentation for the final capstone project. Thank you.